I'm connecting now. All right, let's get started. So, hi everyone. We would like to start the last but not least, the session of Thursday Gathering 138 from 8 p.m. is STEAM for Innovation. This is a series of the session, and we have this series, 3 session series from now until 4th of March. But the first session of the series is the Art of Science and Science of Art. So this session is organized by OIST, Okinawa Institute of Science and Technology Graduate University, and OIST Foundation. So today we would like to welcome our wonderful speakers, Dr. Kenji Doya, who is a professor of Neurocomputation Unit of OIST, and then also Ms. Eiko Kano, a violinist and OIST Foundation Music Ambassador. And then today's moderator is Mr. David James, Senior Advisor to the President for Institutional Development, OIST and Managing Director of OIST Foundations. So I would like to pass it to David. So the floor is yours.
Thank you so much, Lisa, and good evening to everyone joining us from Japan. And for those of us in the United States, it's a nice early morning. So good morning to those joining from the US. Again, as Lisa said, I'm David James with OIST and the OIST Foundation, and I'm joining you from New York, as is Eiko, and Kenji Doya, who you'll hear about in a moment, is joining from Okinawa from OIST campus. I want to thank Venture Café Tokyo, and in particular, Lisa and her colleagues, for allowing us to partner with them on this particular event. And as she mentioned, it is a series of 3 connected dialogues. Very quickly, you're going to hear more about OIST, in particular from Professor Doya in a moment, but I just wanted to, for those of you who don't know, give you just a sentence or two about it. OIST is the Okinawa Institute of Science and Technology Graduate University. It's an interdisciplinary graduate school that offers a 5-year PhD program in science, and the main task of OIST is to produce groundbreaking, cutting-edge research that benefits all of humankind. The OIST Foundation is a US-based 501c3 nonprofit organization, and we support scientific breakthroughs, innovation, and the sustainable development of Okinawa through OIST. Let me tell you just a little bit more about the 2 amazing panelists who are so kind to join us for this very interesting dialogue on the intersection of art and science. Kenji Doya, as you heard from Lisa, is professor in the Neural Computation Unit at OIST. He's one of the longest serving professors at OIST, so knows the history of the institution extremely well, and you'll hear about it from him in a moment. He's received numerous awards for his research, including the Donald O. Hebb Award from the International Neural Network Society, a Commendation for Science and Technology from the Japanese Ministry of Education, the Brain Science Award on Creativity, and many others. He served as vice president of the Japanese Neural Network Society, and he was director of the Neuroinformatics Summer School. And he served on the board of governors of the International Neural Network Society. So real pleasure to have you with us, Professor Doya, joining us again from Okinawa. And Ms. Eiko Kano, joining us from Manhattan, New York City, is, as you heard from Lisa, violinist and OIST Foundation Music Ambassador. She has been praised as an artist with electrifying intensity and lyrical expression by Kyoto newspaper, and a mesmerizing interpreter by Ongaku no Tomo magazine. She's known for her very dynamic and sensational performances, and she has a thriving international career as a soloist. She's played with many distinguished artists, such as principal oboist of the Berlin Philharmonic Albrecht Meyer, Eugene Drucker of the Emerson Quartet, and Ani Kafafian, while working closely with living composers premiering new works. She's won many top prizes, such as the 4th International Competition of Tokyo, and she is concertmaster and senior artistic advisor of Pegasus, the orchestra based in New York. Now, before I turn it over to them, we thought we would start with a little bit of art. I want to show everyone a 2-minute or so clip of Eiko playing a piece of Vivaldi's Four Seasons. This one is Summer. So let me share my screen, and hope you can all enjoy this. Well, I think many of us are longing for summer, but Eiko, let me turn it to you. I think very appropriate that we start with an amazing musical piece that has a focus on nature. Right there we see an intersection in a way between science and nature that has inspired music. Could I turn it to you to talk a little bit about that clip and maybe a little bit more about what you're doing at the moment?
Hi, everyone. Thank you so much for having me. I'm Eiko, and the piece that you've just heard is composed by Vivaldi, Four Seasons, very, very famous, well-known piece. And I strongly believe that the mother of all creativity, science or arts, is nature, really. And then I thought this would be the perfect piece to open the tonight webinar. And the particular movement you've just heard is Summer, and it's trying to create a summer storm. So that's why it was so stormy, and so I hope you enjoyed it. And I'm absolutely fascinated by how music and science can merge together. And so this is a great honor for me to be here. So thank you so much for having me.
Thank you so much, Eiko. And we'll, I think, return to that theme many times throughout this conversation. Let me turn it over to you, Professor Doya. Kenji, if I may. I know that you have some slides you'd like to share a little bit about OIST, and I think it would also be interesting as you do that to maybe just, if you have any reflections on Eiko's particular sort of thought that nature, is really kind of an inspiration for creativity, both in the arts and the sciences.
Okay, yeah, so let me share some slides. Can you see?
Yes.
Yeah, so this is the kind of a drone shot of our campus. So this is in the west coast of Okinawa, and overlooking the beautiful ocean and coral reefs. So, and the idea of having this international interdisciplinary university started around year 2000. And then in 2004, actually, there was what was called initial research project. It's a kind of test project to see whether it is feasible to have a world-class research institute in Okinawa. And then I was one of the volunteer as the participant for this test. And then I was accepted as the kind of guinea pig for this grand experiment. And then fortunately, this turned out to be practical. And now we have quite a well-developed campus with 80 faculty members. Right. So, but important aspect of OIST is that more than half of the faculty and the students are from outside of Japan. So it's really international, the official language English. And also we have no department. So people in physics, mathematics, and biology and environmental science, they are all kind of intermingled. So that's the kind of interesting feature of OIST. Yeah, and but still we are rather a small institute. So if you take some statistics and then divide it by the number, so the result can be sometimes very high. And last time in one of the Nature ranking, we were evaluated as like the world top 9th, a little bit above Stanford and Massachusetts. And this is a quite a unique research environment. And in addition to doing research, we are also quite active in the cultural events. We have a nice auditorium. And just a few years ago, we hosted what we call the world first artificial intelligence art and aesthetics exhibition. So this was like a joint effort with an artist, Nakazawa-san. And you can still go to those websites. So maybe another, yeah. Yep. Yeah, so the record of that event was actually published by in a kind of a book, and we can check what we did in this event. So and basically our campus was full of like exhibits, and also we hosted many concerts as well. Right. Okay. Yeah. So and I'm very glad that Eiko joined as a kind of a cultural music ambassador to OIST to further strengthen our link with not only science but also our culture and art. Right. Yeah. So. I want to ask Eiko how you became interested in not only in art but also science as well.
That's a very good question. As a musician, I always felt that there is unexplainable science in what we do. We cannot put it in numbers. We cannot tell exactly what's happening, but it's in rhythm or it's in energy. It's something happening in our brain and in the body. The chemicals go through as we perform. So when I encountered people at OIST, at their OIST Foundation's first launching gala, I was talking to many people. I listened to what the scientists were giving presentations, and everything felt so like, what do I say? It just clicked in me. Oh, this is something I really wanted to do for a long time. And then, like everything we talk about, especially with David that I work closely with, we never, we cannot stop talking about what we can do together and what we want to do together. So especially when it comes to neuroscience, there is a lot to do with, a lot can be done to reflect onto what we do as musicians into practical practice, like how to prepare for the stage, how to prepare ourselves for big stage, when we get nervous, and how we deal with muscle movements. I think it all comes from brain in the end. So I'm so, excited to talk with you today.
Yeah. Actually, so I also work on robotics, and compared to today's robots, how the people perform in the gymnastics or music playing. So that movement and also sensory motor coordination is quite amazing. So musicians appear to have a kind of instantaneous mapping between the sound in their head and how to move their fingers or body to make that sound actually produced in a flawless way. So that is quite amazing how such a so imagination and sound and body movement are so nicely coordinated. So that is a lot of a source of inspiration for neuroscientists and also robotics researchers.
Yes, yeah. I was just watching a clip a few days ago to talk about how playing musical instruments can do to our brains. And it was interesting that solving math problems or doing puzzles activates one part of the brain, but not listening, but playing actual musical instruments. What's happening in our brain is like a fireworks. All parts of all the brain, all parts of the brain works. So it's like a visually, auditory, kinesthetically, because we play, and then also some motor thing. So every area of our brain apparently is actively coordinating together. So that's why for small kids whose brain is still in process of developing to play instruments.
So Eiko, when did you start to play violin?
When I was 4 years old.
Do you remember your first violin playing?
I do not remember. The only thing I remember at the teacher's first lesson was like I was 4, and then I was so nervous to meet new teacher, and then I could not say I need to go to the bathroom, so I had an accident on that day, and that's my first memory. But now I teach beginners, small child or sometimes adult, and then I'm fascinated how complicated to play the violin. Piano, you just press keys. But then violin, to be able to produce this sound, it just requires so much of bow hold, holding the violin left and right, different things. So I guess that should be good for your brain,
And one thing I'm curious is that classic musicians watch the score, right? So you play the pieces hundreds times or thousands times, but still many musicians want to see the score. Why is that the case? If you don't have the score, you cannot play the same?
Often we perform pieces by memory. But when it comes to orchestra music, first of all, it's so long and so many other people involved. We need to, once we get lost, we need the music, sheet music to get back, to find where we are and what other people doing. But then in terms of evolving one piece of music, it's like when you look at music, you always find something new.
I see.
And I think it's like a sheet music itself has some mathematics beauty in it. Like when you look at it, the great piece of music look great on paper. Like for example, I so wish I could show Bach writing his piece of music on paper. I'm framing it at my room, in my room, but it looks so like it's like a math. It's a beautiful, nothing extra, nothing, just perfect.
I see. So not just the sound, also the vision of the score is a part of that.
I think it's architecturally and mathematically done as well as musically, I believe, because it's such perfection to me.
See.
Yeah.
Right. That's interesting. Yeah. Right. So let me explain a bit more about my research. Yeah. So this is a kind of one of my first research many years ago when I was a student. So this was a time when the personal computer became available to the world. So I tried to do something interesting using my PC. And then what I decided is to make a robot and then make the robot learn, right? So, but when I looked for the textbook, there was no textbook that explains how to let the robot learn the behavior, right? So I thought just myself, what needs for a robot to learn? And I thought, yeah, maybe they need a feedback. So this robot pulls this roller to measure its speed and then explore different movements to find dynamic posture, which let them run as fast as possible. So that was the beginning of my research. And then sometime later, I started to learn that this is something called reinforcement learning. So this agent can be a human or animal or a robot or software, which monitors the state of the surrounding and send some kind of action. And then get reward feedback, evaluate how good or bad this agent is performing. In this case of robot, this rotation of the wheel is the reward signal for the robot. And this kind of a framework can be applied to many situations for many creatures. So the reward can be food or water or avoiding pain. And for humans, reward can be money or social fame, but the similar principle can be used for many different situations. So now reinforcement learning, kind of very important topic of, so not only in like artificial intelligence and also for the neuroscience. And that's why I have both artificial intelligence and neuroscience subgroups in my lab. So they can share the same idea for the applications and assessing how the brain works. Right? So for example, this is one of our early work to let the robot learn to stand up after many like a trial and error. In this case, we gave a reward based on the height of the head from the floor, and when they fell down, we gave some punishment. But after some trials, the robot could learn how to stand up without not explicitly taught how to do it. And more recently, we are building a kind of a colony of robots which is based on survival and reproduction, just like living agents. So these robots live on this battery pack, and when they well fed, they start to look for a kind of mating partner. And these robots, they found out each other, and they are now using infrared communication to copy their genes, kind of important parameters of the program. So this way we can implement the evolution of the program among robots. So that's the kind of a study we have been doing. And the interesting thing about this reinforcement learning and also the evolutionary computation is that there's a lot of degrees of freedom the robots learn or evolve. For example, my former postdoc, Stefan, found that in some cases, there are kind of different types of robots in the same colony. So interesting situation is that when you find a battery on one side and other robot on the other side, so which you approach. So those green guys always go to the battery pack, and this red guy kind of keep track of another robot and look for kind of mating opportunities, like hungry guys and romantic guys. And then Stefan performed a gene analysis of the robots, and he found that there's a kind of a heterogeneity, two subgroups indeed among these robots. So, and also he showed that they can stably coexist. So, and this way, by giving more freedom to the robot by learning and evolution, we can find a kind of behavior which never predicted when we designed the robot. So, and then we are hoping that these robots or AI may someday become more like a creative, right? So that's the one thing, topic, the reason why I'm interested in art as a part of a question about what is the reward for the humans and animals, right?
Mm-hmm. Yeah. Wow, that's fascinating. Fascinating. Yeah. So one day the AI may be able to create music and perform music. Do you think it's going to be?
Yeah, so already AI or computers are used in many parts of art. Like, so there are some programs to produce a music piece or help people produce music piece. And also, yeah, so there are recent programs which learn from many pictures of like a Gogh or like a Rembrandt, and then reproduce something similar. Yeah, but they are in the framework of what we call like a supervised learning or self-supervised learning. Get this many example and then produce something similar. Right? So the produced piece is not exactly the same as the data used for training, but it keeps the similar feature of the original data. So that is not really creative, right? So then how the AI can create something new, or how humans create something new? So that's a very kind of a fascinating question. So if we understand how people do creative activities, we may be able to reproduce in computer, but that has not been achieved yet. So we still need to find out why we feel something beautiful, something enjoyable, and then how people find interesting pieces or interesting or appealing ways of playing. So yeah, that is a fascinating question.
Yeah, that's exactly I wanted to talk with you today. Like the biggest difference in AI we know now, and the pieces of music, how it's been created, is like a composer's pain, joy, sadness, love. The raw human emotions are completely the foundation of those great pieces of music. And not just classical, like Beatles, Queens, all areas, great music comes from their own very human experiences. And then if AI could feel that, experience that and feel it, and then put it onto paper as notes or painting, that's something that I love to see. And what do you think? If that could be done, then AI can feel my feelings without me saying, then that AI can be a dear company for elderly citizens, who lives alone, and they can have very human conversation or relationship or connections with each other. And that will be a wonderful, wonderful contribution to our world, I think.
Yeah, so I think the art and the music is very much related to our being as a living creature, like a survival and reproduction, right? For example, we feel the bird songs are beautiful, and they are a kind of a love call from the male bird to female bird. And also we feel that the flowers are beautiful, but the flower is a part of their reproductive behaviors. They use create beautiful flower to attract insects, and then that will expand, help their reproduction, right? So even in those animals and plants, the beauty is related to reproduction. And humans also sing a song or create something appealing. So often that is for the sake of getting attention on other people, or in some cases to express the love or loneliness of a heart. So so in order for the art or music to be really kind of attractive, not just mimicking the surface of the expression. So probably it is important for the performer to have its own life. So how he or she can survive, how she or he can have partners, and then maybe reproduced either biologically or socially, culturally. So when the artificial agent to come to that level of human-like or animal-like activity or mind, so they may be able to start to create something really new, and that could be attractive, right? So yeah, there's still many steps to go, but there's already some artificial intelligence researchers working on that kind of topics. So this is called intrinsic reward, right? So this is a kind of a so this is the Sony robot. This robot is a kind of moving around in the environment, and then find things in the surroundings and trying to learn the features of the world. For example, if you pat this object, how it swings, right? And then as he performs and learns the structure of the world, such kind of a learning can be a part of the enjoyment, right? Another possible source of reward is controlling your body or your surroundings as you wish, right? So this is another concept called empowerment. So the being able to give a good effect to the surroundings. So this is a case of a physical effect, but probably how you can socially affect other people's mind. That is also kind of source of reward for actual creatures and also for humans. Yeah. So how to make something like curiosity or the enjoyment for its own sake, not directly linked with survival or reproduction. That is a very hot topic in AI research these days. Yeah. And we should have a lot to learn from the musicians or artists in that respect. Right?
Yeah. One thing I would like to ask Dr. Doya is often when we perform, we get nervous. I'm sure everybody, you know, before the presentation, before the competition, I mean, athletes also experience, you know, before Olympics, you know, we can only imagine what kind of, you know, the mental strength is required. And I would love to know that which is first, like brain controls our feelings or our feelings. I mean, heart is another fascinating organ that we have in our body, that this heart feels so much, but then does it come from brain or does it come from heart and then send signals to brain?
Yeah, so I think this is not a kind of a one-way street. So there's a kind of a bidirectional interaction between the brain and the body. So heart is one thing, and also our intestine also have a lot of a connection with our brain. So such some change in the brain may affect your body state that further amplify the effect to their brain. Yeah, so it's sometimes this interaction can make your interaction in a good way, and in some cases, unfortunately, it end up in a negative kind of interaction. So yeah, so very small difference at the beginning may let you fall into a different state of this complex interaction.
I see. The reason I like to ask that is like I went to music school, as, you know, growing up, and then a few people know, you know, like more than a handful of people experience the trauma, and you prepare, you dedicate your whole life for that one performance, and you get so nervous and you basically mess up. Or sometimes, you know, because of excessive nervousness, people can go blank. You know, like they could play the piece from memory with no problems, but then, you know, because of nervousness, they could go blank, and then that kind of experience is very, very traumatic. So I love to, you know, for younger generations who are studying musical instruments, and you know, they cannot avoid performing in public, and then so I love to know how to control by having a knowledge what's happening in our brain in the state of being so nervous, because it's nothing like we try to mimic the situation at home. Okay, let's perform as if it's a concert or competition, but nothing is like it when you get out there. So that, you know, like if we know what's happened, what will happen to our heartbeat. I mean, our heartbeats will go so fast, and our muscle is a little bit like, you know, stiff or something. Is many things are different, and if it comes from brain, and if we know what's happening to our body, then we may be able to deal with it better, if not control it. I thought.
Yeah. So probably important thing is whether you can detect a very early signal. So then you can make some kind of a counterbalancing. So not only the brain, but also your body, like taking a long breath is a very common thing. But you may change your clothes or do something different to put your body and brain in a different condition. So probably each person have a different way to escape from such a kind of a negative loop. But if you find out probably you can escape from such a traumatic situation probably better. And also having some successful or happy experience and recall such the good cases that is also I think very helpful, right? Yeah.
So
sorry. Yeah.
Oh no, we have a couple of questions from the audience, and one relates to this a little bit. And I wondered if I could just ask you, Professor Doya,
Yes.
In terms of this kind of reinforcement learning and the two-way. The particular question is, do you think is it possible for AI someday to become powerful enough to engineer the action and reward learning system to make itself more advanced without human supervision? Or do you think that AI is always going to have to depend on humans to develop? So, in other words, is it possible from AI to learn from itself? Or do you think it's always going to require sort of that human interaction?
Yeah, I think it is well possible. Yeah, but probably it is better, and then what they choose to be like selected by humans rather than just living on their own. So by interacting with the human society, they would be probably better off. So to do something which is well evaluated by the human society, that could be an incentive for the AI and robots to learn something new, right? So that's how I think. So.
And there's a sort of related question, which sort of looks at this from a different angle. And it says, do you think that the learning step of robots can also be applied to understand the learning steps of humans?
Yeah. So to some extent. So in a very detailed level of implementation, so robots use silicon and motors. We use neurons and muscles. So they are quite different. But at some level, more abstract level, they may share the same mechanisms. And actually, so that is the one strategy we have been taking. For example, for robots to learn behavior, they have to learn how good it is to take this action or how good it is to take this action. So learning the goodness of different action is a very important thing. And we decided to look for what is the neural correlates for that. We looked at the function of what is called the basal ganglia. So this is a center part of the brain surrounded by the cerebral cortex. But the important feature is that this basal ganglia receives a strong projection of the neurotransmitter called dopamine, which is known to signal reward. So then this stratum may evaluate predict how good it is to be in certain state or how good it is to perform a certain action in a certain state. And that was the kind of a hypothesis we came up based on reinforcement learning theory, which has been developed from the AI and the control theory. And such kind of hypothesis will guide us to design the experiment. Indeed, so this is our recent work of measuring the activities of neurons in the basal ganglia, and then using this tiny microscope to observe the activity of neuron, and we could demonstrate that these neurons can indeed work for predicting the forthcoming reward from a sensory cue. Yeah, so the theories used for the training robots or AI, that is also helpful for our progress of our neuroscience. So I think that's a very good reason for the neuroscientists and AI research to work together. Right.
I see.
Yeah. I had a question that maybe is for Eiko, but for both of you really, which is about, and it relates to the kind of, I think, core of a lot of what you've talked about, which is, you know, the difference perhaps between mimicking and creativity, and what is creativity. I wanted to ask particularly about imagination. You know, Einstein's favorite quote was something like, you know, imagination is more important than knowledge. And of course, I know Eiko has told me a lot about Einstein's love of the violin. How important, Eiko, is imagination in the sort of works you play? You know, there seems to be, based on what I'm hearing from your conversation, there seems to be this period of intense learning and mimicking of you know, sort of the notes in front of you, but then you reach a point where you can almost be sort of free and have a kind of imagination of how you want to take the music. How does that play into what you do?
First of all, I think mimicking itself has its own art forms, and like, you know, the lot of fine art students copy great masters' paintings over and over, and mimicking. The Picasso once said, "Good artists mimic, great artists steal," and and like, but mimicking itself, I believe it will open the doors of one's creativities. I believe. And by mimicking, it's that. But then the imagination, when it comes to creativity, everything, like, I'm sure it's in science too. We long for something. We want something beautiful. We want something convenient or better in life. So that comes from imagination. What if I could play with this color of sound? What if I could produce my pain in this sound? You know, so it's just the without imagination, the piece of music becomes just notation. And what's fascinating is when it comes out, the same pieces of music come out completely different if it comes out through me, if it comes out from somebody else. So why is that? Because I experience my own life, and then the other people experience their own life, and we have different way of feeling things. And that's the beauty of art, I think.
So when you kind of imagine about or play of music, so in addition to sound, does it evoke your vision? So you talked about nature and music at the beginning of today's session. So for example, watching a certain scene or something other than sound can evoke sound, the imagination of certain sound or music in your head?
I do, and then like it's funny enough, like the temperature of the air, the how the breeze is blowing, wind is blowing, like everything we feel, I do have particular picture in my head. Music is like artwork to me. Which color, which line, what is the main theme, and and then sometimes I feel the temperature. I want more cold sound. I want more warm sound, and so it's just I cannot separate. This is music. This is fine art. This is architect. It just comes all together when it comes to polishing up the pieces of music.
Yeah, so such a kind of an instantaneous link between different modalities, like a vision, sound, and the motion. That's a very interesting feature of a human association and the imagination. Right?
In neuroscience too, the beauty of human brain is like there's still a lot to be discovered, and so that's, I don't know who made our brain, but I think that's absolutely fascinating.
Yeah. So actually, recently, one of my major research topic is called mental simulation. Right? So we can simulate the effect of your action. For example, how your body responds to your muscle movement, or how your friend responds to your words. Right? So we always run such a simulation before actually taking important action. Right? Although we do make a lot of habitual behaviors. And then how our brain can run such simulation in a flexible way is a very fascinating question. So today's computers are very good at simulation once we write down the equations. But our brain can run a lot of simulations in a very flexible way with nobody writing down the equation, just from the many pieces of experience. So so how that is realized, how we can fast forward or wind backward. So so the mechanism and the control of the simulator in our brain. I think that's a very important target of neuroscience today. And then if we better understand it, probably we can make our robots and AI much more flexible and creative. Right?
I see.
Yeah.
Professor Doya, I have just a question for you. Your research is absolutely fascinating. And I'm wondering, what was the most surprising thing in terms of some of the results that you found? I mean, I found it surprising that, you have, I forget how you called it, the romantic type versus the hungry type. Was that an outcome you were expecting in some of your research, or were you surprised by that? Or are there other things, especially in this intersection between sort of what it means to be creative and have an imagination and to be sort of more human-like versus what we often think of as a kind of non-human?
Yeah. So that like a hungry robot and romantic robot, that was absolutely unexpected, interesting finding. And we do have some experiments to test a certain hypothesis. And when it turns out to be true, I'm also very happy. But often, if we do an experiment, we'll find something more, right? So, for example, we had the hypothesis that in our brain, the chemical called serotonin is controlling the patience, whether you focus on it right now or look in the long run. So, and indeed, by stimulating the serotonin neurons in the mouse brain by molecular technology, we could show that the mouse become more patient for the delayed reward. But in addition, we found that such patience depends on the probability of the outcome. So when if you wait for the reward, the food pellet. And then if it comes out in like a 75% probability, in the remaining 25%, mouse waits are quite long, especially with the serotonin stimulation. But when he knows that the food pellet comes in only 25% of the time, so no matter how strong you stimulate the serotonin, they don't wait. So such like a confidence and the serotonin has a kind of a interaction. That was something we found by doing the experiment, and which we didn't experience before doing the experiment. So that is a kind of a very amazing and then kind of exciting situation. So yeah, so when your hypothesis is proven, that is good. But when you find something you never imagined, that is furthermore kind of exciting and opens up the direction for new research. Yeah.
We only have about 4 minutes left before we have to close. So let me ask you, Eiko, a similar kind of question. If I could imagine each performance that you give as kind of a lab experiment, same question. What's been the most surprising to you? You know, in a performance. Did you, I mean, I'm just imagining here because I don't perform, but you know, I could imagine you're playing a piece and you do something that you didn't expect. Same question. Has there been something kind of unexpected
unexpected?
Yeah.
Sometimes it has the beauty of live performance is that we share the same space, we share moments together with audience who came at that time on that day in that place, in a specific location, and then we perform, and then sometimes I feel that my energy and audience energy becomes one. We breathe as one organism, and that's absolutely like beautiful moment. And the silence we experience within that kind of performance is nothing like other quiet, the silence. The silence itself has many different kinds, but then when our energy becomes one, and as we breathe as one being, it's nothing like it in life. And that's the most, I wouldn't say it's a surprising moment, but it's the most fascinating moment. And then I think that's also, to me, science, how people's energy can become as one, like our frequency or vibration completely resonates. 100 people together, we feel that we are one. And so I believe that music exists to connect people together. So that's science. So, as long as I feel that beautiful moment, I cannot live without music. So that's me.
Well, please do.
I really hope that the time when we can actually meet together to play and hear music.
Yes, absolutely. I cannot wait either.
That's going to be great because, we've gone through an hour and I feel like we could have 20 more hours and there's so much more I want to hear. But we have to sadly end, but let's just consider it a beginning of many other interactions between both of you. And let me just say a few things. One, I just want to thank both of you. That was an extremely rich, fascinating conversation on, I think on topics like thinking and creativity, imagination, how we feel, and fundamentally what it means to be human, and how can, an AI system, kind of get close to that. I mean, these are absolutely fascinating topics. So I hope the audience found this rich, and I look forward to talk 2, 3, 5, 20, 50 on this topic with both of you. So let me thank you both very much for the time. I want to remind the audience, as Professor Doya knows very well, that, and so does Eiko, This year is the 10th anniversary of OIST, and in November there will be a ceremony and celebration of this. And Eiko will be performing, and Professor Doya is deeply engaged and will be there as well. So perhaps there'll be time there for a continuation of the discussion. Let me thank Lisa from Venture Café again, and thank the audience. Lisa, I don't know if you have any final things you would like to say or direct us to the next room, but again, thank you all very much, and have a great night and a great day if you're waking up in the United States. Lisa, any final comments, or are we good?
Yeah, thank you very much. It was a wonderful session, and I know that there's a lot of great questions. So if you would like to have a chat a bit more with wonderful speakers here, we can jump into the networking space. But before that, let me share about the session for the second session for this series, which is happening next week. So we also have a STEAM for innovation session. Next one is diving into educational about the STEAM education, what is the current situation, and then what is the future perspective for the STEAM education, which is happening in Japanese for the next one. We also bring a wonderful speakers like here. So come to join us, and then let's also have a chat more about how we can change the world with STEAM. But thank you so much today, David, Eiko, and Kenji. It was a wonderful session, and if anyone would like to join to the virtual networking space, have a bit more chat with wonderful speakers. Now I just put into the chat, but please come to the virtual networking space, which is called Remo, so we can virtually have a bit more smaller conversation with wonderful speakers. But thank you so much.
Thank you very much.
Thank you very much,
everyone. Have a great night and a great day. ありがとうございます。
はい、ありがとうございました。
どうもどうも。
Thank you.